Hello. All right. Today's PowerPoint is about proving congruent triangles. Proving triangles are congruent. And remember that proofs are all about defending yourself, your knowledge, and your assertions. So, defending your knowledge, defending your assertions, how do you know what you know? Can I trust what you know? What evidence do you have? Etc. And remember that we always use postulates, like side angle side, side side side, etc. Those congruent triangle postulates to prove that triangles are congruent. So here are the steps to completing the proof. Remember that we currently, well, I'll get into this a little bit later, but remember that these are our steps to completing proofs regarding triangle congruence, and they'll be on every slide. Here's our first. It says, given that JM equals LN and angle JMN is congruent to LNM, then that's the only two pieces of information that you know. Then you have to prove that the entire top triangle is congruent to the entire bottom triangle. So it says step 1, write the given information into the proof and make your marks. So our first piece of given information is that JM is congruent to LN. So it's already written right here. Because remember, this is what I was talking about on the previous slide, that right now we have all this provided for us, but in the future we're getting to the point where you don't know any of these things, and you don't know any of these things, and you still have to do all these proofs. So first piece of given information, it's already written into the proof, now we got to make our marks. So JM is congruent to LN. Also, so there it is in the proof, and then the reason is, like, how do you know that JM is congruent to LN? Well, you know because it's given. Second piece of given information, that angle is congruent to that angle. And remember, knowing which angle of this 1, 2, 3, 4, or 5, or 6 angles is important. So we've already gone over that. I'm not going to go over it now, but just remember to be careful about which angles you're marking as congruent. So, given information, we've made it into the proof right there. We've made it into the diagram up here. And the reason that we know it is it's given. Well, now we have to write any hidden information. And remember, we're only dealing with 3 pieces of hidden information: reflexive sides, alternate interior angles, and vertical angles as of right now. So we know that here is a reflexive side. And then we wrote it into the proof, and then the reason that we know it is, well, it's the reflexive property. It says that that side is congruent to its own self. And then if you just look at the top triangle, we do have 3 pieces of information. We've got a side, and then we've got an angle, and then we've got a side. And if you look over here, we've got a side, and an angle, and a side. So we can automatically say that the 2 triangles are congruent via the side angle side postulate. So we're done. Alright, now the hidden information, right now we're really kind of only dealing with a few. The most common ones are reflexive property. I'm not going to draw, I guess. So we've got reasons that sides are congruent, well, if it's given, or if we've got a midpoint, then we know that the midpoint means directly in the middle, which means that the 2 sides are congruent to each other, or the reflexive property. Reasons that angles are congruent, well, they could be, given that they're congruent, or they could be vertical angles, because vertical angles are always congruent. They could be alternate interior, they could be alternate exterior, they could be corresponding, and this symbol, this bracket right here, is to help you remember that these 3 things only occur if you have been given via a given piece of information that 2 lines are parallel to each other, or if they have the little parallel arrows, but in both of those cases, it will show up somewhere that the two lines are parallel. If it looks like they're parallel, but it doesn't say it in any way, shape, or form, then you can't use any of those three. You could also have an angle bisector. Or also up here on the sides, you could have a segment bisector. Remember, the word bisect means to cut, sect means to cut, and then bi means into two, to cut into two equal parts. So remember this as hidden information. We'll look at it again in a little bit. Here's our next proof. Given PQ equals ST, given QR equals TR, given R is the midpoint of PS, we'll then prove that the two triangles are congruent. So step 1 says, write the given information into the proof and make your marks. So, given number 1, PQ equals ST, PQ equals ST, write it into the proof, give your reason. Well, it's given. Number 2, given piece of information, that is congruent to that, and you write it into your proof, and, well, it's given. That's how you know. Next one, given information number 3, R is the midpoint, given, given. Now notice on that one we did not make any marks on the picture up here. And that's because unless you want to like draw an arrow and write like given, R is midpoint, or just even an arrow saying like R is the midpoint. But we don't really care that it's the midpoint, except that it gives us a conclusion. Over here, I hope that this thing is recording where I'm pointing with my mouse, but the conclusion that we can draw from R being the midpoint is that, these two, PR is congruent to SR. So remember, if R is in the midpoint, it means that it creates two equal chunks. So then we gotta write it into the proof, and then the reason we knew was because it's, well, just the definition of a midpoint. Whenever you see the word midpoint, you know you're probably going to be using a definition of the midpoint. And notice that the midpoint here is in green. We still have to write that into our proof, even though all we actually care about is the conclusion that we drew from that piece of given information. Then we've got 3 sides, and we know that the two triangles are congruent. So remember, vertical angles, alternate interior, alternate exterior, corresponding, angle bisector, going up now to the sides, definition of midpoint, definition of segment bisector, or reflexive. Alright, another one. I know I'm going really fast, but you can rewatch this as many times as you want. Or pause me in the middle, whenever you need to. So step 1, write your givens. So YZ bisects angle WYX. So we're going to write that in the given. And we're going to, oh no, I didn't make my marks. Well, there's no mark to make necessarily from the bisecting, but remember it's going to have a conclusion that we can draw from that word bisect, and it'll tell us something. It'll tell us that that big angle, WYX, is cut in half. So second piece of information is that this angle is congruent to this angle. We're going to write it inside the proof and give our reason. Now we're looking for any hidden information. So hidden information is this reflexive side. YZ is congruent to its own self. And the reason that we know is it's a reflexive side. The reflexive property. Oh, I should go back. So now we're going to do our conclusion. We know that we put it in our proof, but we didn't make any marks for this red piece of information. And what we can conclude from this word bisect is that it cuts it directly in half. So therefore, we can say that that is equal to that angle. So we're going to write it in there and give our reason. Give our reason. And then now we look, we look at our triangle. Just just look at one of them. I'm going to look at the left, and we've got an angle, and a side. So we can say that the angle, side postulate says that the two triangles are congruent to each other. All right, I think there's just one or two more. So step one, write your given information into your proof and how you know. Another piece of given information, make your marks, write it into the proof, say how you know. Step two, write the hidden information into the proof and make your marks. So I see a reflexive side right here. So I'm going to say it's equal to itself. I'm going to write it in the proof. I already made the marks. And I'm going to say how I know. Well, it's because it's reflexive. So, ooh, this one we haven't talked about very much, but I only have two pieces of information. However, I know that already I can say that they are equal because remember, for right triangles, we're not going to use like side angle side or angle side angle, anything like that. You just need one of the legs to be congruent to the leg of one of the legs of this triangle, and then also the hypotenuse. So we're going to use the hypotenuse leg postulate to let us know that the two entire triangles are congruent to one another. Oh, that was it. All right. I hope that I didn't go too fast. You can slow down the video on YouTube if you hit the settings and then playback speed. So that was just some additional practice. I hope that I articulated my reasons well enough, and specifically how to use this step by step. Especially at the beginning, it's just going to be given and hidden information, but some conclusions. The conclusions are going to be primarily, what does bisect mean? What does midpoint mean? Etc. Or what can we conclude from us knowing that those words are there, and what do they say, and what does it mean? All right, good luck.